Chapter 22, Reaction Kinetics. So in this particular lesson, this is a quite new lesson for A-level students because there will be many things that you have not met in O-levels or in AS part of this. So basically we will be talking about the rate of a reaction and the different steps that are involved in a chemical reaction, because you will learn that a chemical reaction does not take place, the whole thing does not take place at once. So there are different steps involved in it. So to find the rate of something, now when you to find the rate of anything, you can actually look at two sides, that is the start or at the end. You can look at the end product or the beginning. Now when it comes to a chemical reaction, you can actually look at the reactants or the products. So how fast does the reactants get spent, and then how fast do the products form. So these are the two different ends of this rate relationship. That is, how fast do the reactants get spent, or else how fast do the products get made. So now in O-levels you have learned that the rate of a chemical reaction can be increased by different methods. We have learned about how to increase the yield. Now to increase the rate of the reaction, yield and rate are quite different, but to increase the rate of the reaction, you know that if you increase the concentrations of the reactants, can you remember why increasing the concentrations of the reactant would how that would affect the reaction, the rate of the reaction? If you look at a sample, you would be able to understand that. Now, for example, let's say this whole white space is for the reactant. So this reactant A should react with this reactant B. So now if only A and B are present here, so you know that for them to join up and make another product, right? So this has to go and collide with this. So then in the end you will get an AB, you will get the AB structure. So this whole thing would be a new product. So now if only A and B are present, the chances of them, because these things can go here and there, it will take some time for it to come and collide with one another. But if there are more than one of these things, that is, if there are more of B's and A's, more B's, and at the same time there would be more A's, then what will happen? There are more chances for these to collide with one another. So that is how the concentration would increase the rate of a reaction. So then the temperature is increased. Can you remember in O-levels we have learned that when you increase the temperature, the kinetic energy contained in these molecules would be higher. So these would have a higher kinetic energy, so they have a higher vibration, or they have a higher amount of energy, so they can move faster. So the faster they move, they can actually go a higher distance at the same time in comparison with other low temperature environments. So they have a higher chance of colliding once again. So in that sense, so they collide and the reaction would take place. Then a catalyst is added. So when a catalyst is added, the activation energy is reduced, right? So that is again one thing that we have learned. So as a result, the reaction rate would also once again would would increase. So now we will be looking at something called the rate reaction. So basically we will be looking at different aspects of this rate of a reaction, the quantitative aspects of reaction rates, that is the values involved in it, then how the data that are there in different parts of in relation to different parts of the chemical reaction, how do they get involved in the chemical reaction, and also how do they indicate that a reaction can happen, right? So that is then also that is the possibility of a reaction, whether it is possible. Then also we will be able to find out the mechanism of the chemical reaction. We will come to those parts. If it does not make that much sense, that is fine. Then we will be learning about how do these catalysts actually do the real work there. So please write down the note. The rate of a reaction is basically a measurement of how much products are produced within a given time, or how much reactants are used up during a given time. Leave a line and write. The rate of a reaction can be increased by, number one, increase in the concentrations of the reactants, increase in the concentrations of the reactants. Number two, increase in the temperature of the system. Number three, adding a catalyst to the reaction mixture. Then we have to look at the rate of a reaction. So obviously the rate of the reaction is in relation to time. Therefore, we can take it by change in concentration divided by time taken for the change. Right? Rate of reaction is equal to change in concentration divided by time taken for the change. Right? So now this concentration of what? We can actually use anything. The decrease or the reduction of the concentration in a reactant, or the increase in concentration of a product over a certain period of time. So you can pick anything. Rate of the reaction is equal to change in concentration of one, that is change means either the reduction of the reactants or the increase in the products. So obviously the concentration units are in mole per cubic decimeter. So the time is in seconds. So the rate of the reaction would be normally mole per cubic decimeter per second, right? But if the rate is very, very slow, in some chemical reactions do not take place very vigorously. Now if you take sodium reaction with water, it would be vigorous. Then you can find out how it acts in seconds, mole per cubic decimeter per second. But if it is taking more time, then we can take it to be mole per cubic decimeter per minute or mole per cubic decimeter per hour. Write down the note. Rate of the reaction the rate of a reaction can be calculated by finding the relationship of the reduction of the concentrations of reactants, the reduction of concentrations of the reactants, or the increase in concentrations of products, in relation to time. Then you must write down the equation. Rate of reaction is equal to change in concentration divided by time taken for this change. Rate of reaction, you can see it on the video. Rate of reaction equals change in concentration divided by time taken for this change. So you can put, now we are to find the change in concentration, we are deducting the final concentration from the initial one. Then we will get, you don't have to actually worry about the signs. You might get a negative value, it doesn't really affect this. So the change in concentration, you will have to write mole per cubic decimeter divided by time is seconds. Then usually it is mole per cubic decimeter per second. But if it is slow, it would be mole per cubic decimeter per minute or mole per cubic decimeter per hour. Leave a line and write. Usually, the rate would have units of mole per cubic decimeter per second, mole dm minus 3 s minus 1, full stop, open brackets. For slow reactions, it could be mole per cubic decimeter per minute min minus 1 or mole dm minus 3 h minus 1, that is per hour. Now I'll give you 2 minutes for you to try the question, try the first question.